So far we can identify that a charged particle sets up an electric field. Okay, that's all we need to learn, kind of. So if you have a charged particle, it sets up an electric field. If you put a test charge or some other charge there nearby, it is going to feel a force because of the interaction. But any charged object will create an electric field around it. So here's a practice question. A charged object sits in the origin, generating an electric field E0 at distance d away. If the distance is doubled to 2d, the electric field will stay the same, has the same magnitude, but a different direction. It drops to half or 1/4 or increases to its double. So all we need to understand is we know that E is given as F over Q, right? So what this say against here too, E is proportional to F, right? And we know that F is proportional to 1 over R squared. So if you double the D, so that D, the R in this equation from the Coulomb law is K, Q1, Q2 over R squared, right? And that R is D, that if D is doubled, R is doubled. When you take the square, that's going to be 1/4, right? And since, again, F and R are inversely proportional, it's actually F and R squared are inversely proportional. So is R, E and R squared. Okay, so if you double D, so it becomes 2D, and square that, it becomes 1/4 of D squared. It goes from 1 over D squared to 1/4 of D squared. That means electric field is also going to drop to its 1/4. Next, we're going to discuss the direction of the force. Unfortunately, here again, the PowerPoint doesn't show all the figures I have in this. I mean, you already have it on your PDF, but it doesn't show up here. So first of all, we have some electric field. Okay, I'll try to draw them here. I'm gonna draw as many as I showed in the PowerPoint, but I think this should be sufficient. So these are the electric field lines, and we don't know what the source is. There's apparently some charge distribution that creating this electric field. We don't really care about that yet. So that means this electric field is external to us, and it could be from. We will see. You will have better idea what could generate this electric field later, but we don't know what the source is, and that's not our focus right now. Okay, so we have an external field. So let's just take a note of that. Try to write better. This is an external B field because the source is unknown, and we don't really care what the source is for this for at the moment. So what we're gonna have is you can see it in the figure too. So there is a positive charge here. I'm just gonna put a positive charge. So this is my charge, okay. And right here, let's put a negative charge. The values, the positive is 2.8 and negative is 9.3. So negative one has bigger magnitude of charge. And we will kind of see what's the deal. So electric field depends on the sign of the charge. Okay, so sorry, not the electric field, the direction of the force, right? This is what we're writing. So the direction of the force. So this external E field is I'm just trying to explain that electric field could be external or internal, but this electric field given is external. So the direction of the force depends on the sign of the charge. So if you have a positive charge, you will feel the force the same direction as the electric field. Okay, that's going to be the force on it due to this electric field. And again, let's recall the equation. F is equal to Q E, like this, right? If Q is positive, those two vectors point the same direction. And I hope that makes sense. And if Q is negative, as you can see, the bottom charge, and it also had more magnitude than the positive charge. So it's not just it's gonna feel more force because it has more charge on it, but it also is negative, so it's gonna feel it the other way around. Let's make it bigger, and that's gonna be the force. And let's just say this is on the positive one, this is on the negative one. And again, this one is opposite to the electric field direction because it's negative charge, right? So let's take some notes. Let's go back to this color. So if you have a positive charge, E and F point the same direction. And if you have a negative charge, E and F point opposite directions. Those dots are the items. I'm trying to make a nice circle. A little hard to do that. Let me do it this way. Too big. Oh, that's crazy big. It's okay. I think you got it. Let's go back to this size. And one last thing is E field is the reason. Okay, that's what we are understanding from this relations, from this picture too. Why we have electrostatic force. So now we know why we had electrostatic force to start with, because there was E field, electric field, due to some other charge distribution. Again, that's external to the point charge that we are focusing on here or here. And at the moment we don't really care about it, but we will talk about it soon.